Hi, welcome to the next video on the LabVIEW simulation part. So here we will be dealing with the demodulation of a DSBSC wave. So switch over to LabVIEW. Yeah. So here this message signal and the carrier signal is being multiplied to get a modulated signal. The same modulated signal will be multiplied by the carrier signal at the receiver, which could be generated locally using a local oscillator. After multiplication, pass it through the filter and pick up the low frequency components to get the demodulated signal. So over here I have used the carrier signal, which is of which has got amplitude, frequency and phase. Coming up with the low pass filter, the filter order that is chosen is 1 and the cutoff frequency of the low pass filter is chosen as 20 kHz. Since every message component, that is all the message component which is within 20 kHz, will be passed through this filter. So then both message signal and the demodulated signal are merged and it is seen on the scope, that is waveform graph. Now the spectrum of a demodulated signal is seen after converting the demodulated signal in frequency domain. So over here we'll be having the spectrum graph. So let me go with the front panel. Yeah, so message amplitude, initially it is 3, message frequency is of 5 kHz, carrier amplitude is of 3, carrier amplitude at the receiver is of 3 volts, carrier frequency at the transmitter is 800 kilo, and the carrier amplitude at the receiver is also 800 kilo. Fine. The phase at the receiver is 0. Initially let it be 0. Now if I just run the code, so you can see that the demodulated signal, which is red in color, and this is the modulated signal. So both have got the same frequency. So if you look into the spectrum, so we have an impulse function exactly at the message frequency 5 kHz, demodulated as well as the modulated signal. Modulating signal. Now if I just change the carrier frequency at the receiver side, let me change it to 700 kilohertz. 700 kilohertz. So you could see that the demodulation could not be done. Provided the carrier frequency at the receiver is changed. You could see that with the spectrum also. So this is termed as frequency error. So now I'll make the frequency same as the frequency at the transmitter side. So that is both transmitter and receiver both are in sync. So which means that it is a coherent demodulation. I'll just go change the phase at the receiver side to some, let me say, some 30 degree. Yeah, you could see that there is a reduction in the amplitude of the demodulated signal. So because of the phase, we will be having a cos phi term at the output terminal. So that is why cos phi, cos 30 reduces the amplitude of the demodulated signal. Now I'll just make it as 90 degree. So you could see that cos 90 is 0. So since it is 0, we can't go demodulate the signal. Next, let me make it as 180 or just within 180, 140. Yes, demodulated but with opposite phase. Once again the amplitude is being reduced when compared to amplitude at 0 phase. Now let me make it 180. Yes, amplitude has been increased and yes, it could be demodulated. Anything greater than 180, so let me make it to 30. Yes, once again it is being phase shifted. So let me make it 360, which is nothing but 0 once again. Yes, you could demodulate. Demodulation is, since phase is 0, which is once again 360 degree, which is nothing but 0. Yes, we could demodulate the signal. If phase is changed to any phase that is which is not according to the phase at the transmitter side. So you could see that the phase of the carrier signal at the transmitter side is the default value, so which is 0. I just stop the run. Yeah, phase is with the default value which is 0. So if I keep the same phase at the receiver side, yes, demodulation is possible. Any other phase other than 0, which is there at the transmitter side, so the demodulation is still possible but with reduction amplitude. So this is termed as phase error. So let me make it 0. Yeah, you could demodulate. So this process where phase at the receiver is same as phase at the transmitter side and frequency at the receiver is same as frequency at the transmitter side, then only you could demodulate, and this process is termed as coherent demodulation or coherent detection. Thank you.